What is the area of the figure shown on the screen? This is a question in plane geometry. Label A, B, C, and D. Join line labeled AC. Let angle A, C dot B equals to alpha. Then, angle A, C, D equals 45 degrees minus alpha. Also, let line labeled A, B equals Z. Line labeled C, D equals to Y and line labeled A, C equals to X. Consider triangle A, B, C. By trigonometric identity, 8 divided by x equals to cosine alpha, which we call equation 1. And from triangle A, C, D, for divided by 4 equals to sine 45 degrees minus alpha, we call it equation 2. Let equation 1 divided by equation 2. This simplify to 2 equals to cosine alpha divided by sine 45 degrees minus alpha. Thus, cross multiply and simplify. But sine 45 degrees equals 1 divided by the square root of 2, which is equals to cosine 45 degrees. This implies that cosine alpha equals to the product of 2 and the difference between cosine alpha and sine alpha, all divided by square root of 2. Simplify and we have the equation shown on the screen. Combine like terms and rearrange the terms. Thus, the product of square root of 2 and sine alpha equals to product of cosine alpha and the difference between the square root of 2 and 1. Divide the equation by 2 cosine alpha and we have the equation shown on the screen. But sine alpha divided by cosine alpha equals to tan alpha. And by rationalizing the denominator of the square root of 2, we have equation in tan alpha as shown on the screen. From triangle A, B, C, z divided by 8 equals to tan alpha, which is equals to 2 minus the square root of 2, all divided by 2. Cross multiply and we have equation in z, which we call equation Q. Already we have gotten that line labeled A, C equals to X. By Pythagoras theorem, square x equals the sum of square of z and square of 8. Substitute value of z from equation Q and we have equation in square x as shown on the screen. Expand bracket, multiply out and simplify. We have that square x equals 160 minus 64 times the square root of 2, which we call equation G. Let us find the value of y in triangle A, C, D. Pythagoras theorem. Square y equals to square x minus square 4. Substitute value for square x from equation G and simplify to have that. Square y equals 144 minus 64 times the square root of 2. Thus, y is the square root of 144 minus 64 times the square root of 2. Now we have gotten the values of z and y, we can find the required area of the given figure. Let the sum of j and k be the areas of the two triangles. Hence, area of ABCD equals the sum of j and k, which is equals to the product of height and base of triangle A, B, C divided by 2 plus the product of height and base of triangle A, C, D divided by 2. Substitute terms and we have numerical expression shown on the screen. Simplifying and we have the equation for the sum of j and k as shown on the screen. We need to simplify the radical term, the overall square root of 9 minus 4 times the square root of 2. Let the square root of a minus the square of b equals this radical we want to simplify. Square the equation and equate common or equal terms from both sides of the equation. We have equation 1 and by simplifying the radical equation, we have equation 2 as shown. In all, we have two equations. divide equation 2 by a and we have that b equals 8 divided by a, and substitute it in equation 1 to solve for a in the quadratic equation formed in a. Factorize. We have that either a minus 8 equals to 0 or a minus 1 equals to 0. Therefore, a equals 1 or a equals 8. Substitute in equation 2 for b equals 8 divided by a. We have that b equals 8. A solution set in a and b equals 1 and 8, respectively. When a equals to 8, b equals to 1. A solution set in a and b formed equals 8 and 1 respectively. Two set of solutions exist for a and b. Recall the relationship between a, b, and the radical. A must be greater than b for the relation to be true. This is because the radicand of the radical must be non-negative, and area measuration cannot have a negative value. For this reason, the value of a and b are 8 and 1, respectively. Therefore, the overall square root of 9 minus 4 times the square root of 2 equals to 2 times the square root of 2 minus 1. We return to the equation of the area obtained. Required area equals to the sum of j and k. Simplify the numerical expression by substituting the value we got for the radical. Cancel out equal but opposite terms and the results simplify to 24 square centimeters. Therefore, required area A, B, C, D equals to 24 centimeters.